So let's take a look at an argument that is written in words that we want to go ahead and analyze. We want to know if it is valid or invalid. That's always the question. So the argument we have reads, it is cold and rainy. It is not cold, therefore it is rainy. So first of all, let's understand that these two on the top are our premises. We have two of them. And it is rainy down here is our conclusion. In order to analyze this truth table, we need to assign values to the different statements so that we have what to create a compound statement from. So we're going to let P be the statement, it is cold, and we are going to let Q be the statement, it is rainy. So what we can do at this point is we can actually go ahead and we can rewrite our argument using our letters and our symbols instead of using words. So we have, it is cold and rainy, which looks like P and Q. That's our first premise. It is not cold, which looks like not P. Therefore, it is rainy, which is Q. So we've turned our argument into symbols, and now we know that in order to create our truth table, we actually need to turn this argument into a compound statement. So as a reminder, what we do is we take each of our premises, so we take P and Q, we put an and in between them, so that's premise number 1. That's premise number 2. We've put an and sign in between them, and then we make the if-then statement with our conclusion, which in this case, our conclusion is just Q. So this is what my compound statement looks like. This is what we need to use in order to create our truth table. So here is our truth table. The first thing we're going to do is we're going to go ahead and fill in P and Q. We know that P is always written as true, true, false, false. And Q is always written as true, false, true, false. So we're going to fill that in. Now we're going to look at our statement and see, well, what else do we need? Well, certainly we need not P. We need P and Q. Those are both parts of our antecedent. And then we need to look at P and Q and not P. That's going to be the whole first part of our if-then statement. And then the last thing that we're going to need is we're going to look at everything that's in that bracket, then Q. So that's going to be the last statement we have. So let's start with not P. Not P is just the negation of everything in P. So we have false, false, true, true. And for P and Q, as a reminder, you need to have both of them be true in order for it to be true. And as we look at our table here, the only one that has both true is this first row here. And so we've got true, and the rest of our rows are going to be false. Next, we look at P and Q and not P. So that essentially is looking at this column here together with this column here. And again, since it is an and, we need them both to be true. But looking at all of our columns, we see actually that none of these are true. And so, since none of them are both true, they're all going to have to be false. Now, the last thing that we're going to look at is the entire antecedent, this here, and if that, then Q. That's what we're looking at in this problem. So what we need to do here really, and you have to do a little bit of backwards thinking, is we're looking at this column here, then this column. So we're actually looking at it backwards, and sometimes what I like to do is stick this Q column right in here. Let's just copy this over here, true, false, so that I don't have to look at it backwards, that I really can just look at it going in this direction. And so remember, the rule for if then is if true, then false is false. Now, as I look, here we have if false, then true, if false, then false, if false, then true, if false, then false. None of them say if true, then false. So they all are therefore true. Because again, it's if true, then false is false, and anything else is going to be true. So what we see here is that we actually have a tautology. which tells us that our argument is a valid argument. And we're done.